All right, we're going to look at domain and range. So these are our day one notes. First of all, domain and range comes from this idea we've already looked at before. It comes from ideas of inequalities. So an inequality, we've graphed some of these before. We might say x is greater than 2. Now, x is greater than 2. We know that on a graph that would look like where we have 2, open circle, we recall, and then everything greater than would be to the right. Right, so then we're including everything greater than 2. So 3 is included, 4 is included, but also we're including 2.1 or 2.01. So it's an open circle, meaning we don't equal 2, but we include everything that's right up to 2. Okay. Another thing to remember, if we have something like 0 is less than x is less than or equal to 3, that means we could also write this as x is greater than 0. So we just took this first part and we flipped it around, right? And then because it's all grouped together, we would use the word and we could say x is less than or equal to 3. So how we would graph this one is we have 0, we have 3, everything that is greater than 0 and less than or equal to 3. So when we started graphing these, we would do greater than 0, less than or equal to 3, but the and part we would shade in between here, and that would be our solution. And we would note that this arrow part on the outside of that interval would go away. So in the end, we could also just draw it like this: open circle, closed circle. And some of you started off drawing it that way. Some of you use the arrows. Either way, totally fine, just knowing that those are the same thing. So these inequalities, if we number them 1 and 2, we can also talk about this in another notation. So we have another notation called interval notation. Now this should also be a review, but if we look at these, we'll still look at both 1 and 2 from above. So interval notation, you're looking at what interval are you talking about? So you're kind of like you're reading, you always go from left to right. Same thing here. So for number 1, we're starting at 2. And 2 is, we did have an open circle. So the open circle, I kind of think about it like on the graph here, it kind of looks like a parentheses because it's an open circle. So that reminds me, all right, I do open circle. It's not closed. Closed would mean we would do a bracket. So we have parentheses, and then it's going towards infinity. Now, can we ever reach infinity? No, so we put up parentheses there also. So infinity always has parentheses, and then open circles also have parentheses. The second one, we start at 0, and it's an open circle, so we do parentheses. And we go until we get to 3. Now 3 had a less than or equal to sign, so that's where we put the bracket. So if it's an open circle, or if it's closed, closed we use the brackets, open we use the parentheses. And then also for infinity, we use parentheses. So those are just kind of some snapshot notes from what you should have known before. Another one here is set builder notation. So set builder notation, we're going to change this, is greater than 2. So the first one here, number 1, we would write it as the set of all x such that x, and then our original number 1 here, so we're just duplicating each of these in the different notations, is greater than 2. Curly brackets again. So notice how for this example, we're taking what we had before, so we're taking this inequality and we write it within our set. So remember, a set, just the word set means a set of numbers or a set of items. In this case, we're doing what set of numbers is equivalent to x is greater than 2. So we're saying the set of all x, so the curly bracket means the set of all x, that's what the x goes to, such that is this vertical line. It's kind of like an absolute value bar, but it's just one of them. And then x is greater than 2. We know that that goes to the highlighted part. So this part, we're using the inequality, we're just adding to it. Something you might also see written that's exactly the same as we might specify that x is an element of the real numbers such that x is greater than 2. So the real numbers, remember that's everything on the number line, all the fractions, all the decimals, the whole numbers, the positive, the negative numbers, everything. So sometimes it specifies in our domain or our range what set of numbers we're talking about. If it doesn't, it's assuming real numbers unless it states otherwise somewhere else. And then in interval or in set builder notation for the last one here, for number 2, we can say the set of all x, or x exists in the reals, such that, and then again, we'll just put that inequality back in there. So you have to have this curly brackets around it, and then the such that part, so it's specifying that it's x. If we're talking about range, what variable would be used here instead of x? You guessed it, we would use y. So using these to try to help you and to get you started, here is a chart on the next page. Start this chart. I have one of them filled in for each of them. Then in class, we're going to go over the answers. So as part of the homework, to fill out the rest of this chart, and then we will talk about this together. See you later.